Hey guys, we're going to just do a quick little recap of the information that we have so far. First thing, in a linear function, we use that formula, y equals mx plus b, where m is the slope and b is the y-intercept. Remember, we also refer to this as our starting point. An exponential function, a is the initial value, and b is the factor for y equals ab to the x power. Remember, a can also be referred to as the starting point or y-intercept, and your factor, b, is what you multiply by. It is that pattern of multiplication. We would then take our formula or our function rule equation, and we would evaluate it for some x values. So let's just use -1 through 3. For each of these values where the x is, we're going to substitute our x value. We would evaluate and simplify to get our y. From there, I would take each point, so -1, -1, 0, 2, 1, 5, 2, 8, and 3, 11, plot them on my axes. I've drawn mine slightly to the left instead of centered so that we could get all of our points on here. Now the exponential function, not all of them will fit on our graph because it grows so quickly. However, I was able to approximate -1 2/3. I have 0, 2, 1, 6, and we notice that 2, it doesn't touch that point yet because it's going to come all the way up here to approximately 2, 18. We notice that linear functions are straight. Exponential functions have a curve. Now, their curve is specific because it does not turn and go back up. Linear functions can be referred to as positive or negative, referring to the direction of their slope. Here, our line goes up from left to right, so it is positive. Exponential functions are either growths or decays. Here, ours is a growth. As from left to right, it goes up. So, just a quick recap. We have our linear, negative versus positive. Linear functions can also have slopes that are 0, which we refer to as neutral, or undefined, which would be a vertical line because it's not a function. Using a table, you should see a pattern of addition or subtraction when moving down the table. And then exponential functions would be growths or decays. Growth when b is greater than 1. Decay when b is greater than 1, greater than 0, but less than 1. And these have patterns of multiplication. You can see that pattern in the factor. Now, if we go back up to our table, we should be able to label these patterns of multiplication and addition. Notice here, to get from -1 to 2, we say plus 3. 2 to 5, plus 3. 5 to 8, plus 3. 8 to 11, plus 3. It stays the same the whole time, so this slope is also referred to as a constant rate of change. To actually find the slope, we have to take this change in y and divide it by our change in x, which here is going up 1 unit each time. Exponential functions, for every unit that x increases, y multiplies by a factor. Here we should notice that 2/3 times 3 gives us 2. 2 times 3 gives us 6. 6 times 3 gives us 18. And 18 times 3 gives us 54. So, before we jump into our next thing, take a minute and let's think about linear functions. Attempt the next 2 questions.